Hi guys, your Friendtor Gopika is here, and in this video we will discuss the practice set 3.3. Okay, it's a very simple practice set. In the previous video we discussed two theorems regarding congruent chords and the related congruent arcs. So we will use those concepts and the measure of arc concept in this practice set. Okay, so without wasting time, let's get started. So this is the first question. Let me choose a pointer. So the first question in practice set 3.3 is in the figure 3.37. So that is the figure in the right side. There are points G, D, E, F lying on the circle, and they are concyclic points of a circle with center C. Okay, and angle ECF is equal to 70 degrees. Measure of arc DGF is 200 degrees. We need to find the measure of arc DE, and we need to find measure of arc DEF. Okay, so if you see arc angle ECF is 70 degree, that means measure of arc DCF, measure of arc EF is same as 70 degrees. That is one thing that we can note. And another thing is measure of arc DGF is 200 degrees. That means this particular angle, central angle DCF, this particular angle is also 200 degrees. So if this angle is 200 degrees, that is DCF, and angle ECF is 70 degrees, then the total angle, this total angle is 270 degrees. Okay, so angle DCE, that is a left out angle, will be, we know that full circle means 360 degrees. Okay, full rotation means, here we got that DCF is 200, ECF is 70, so totally this is 70 degrees, 270 degrees. That means this particular angle, the third angle, angle DCE, will be 360 minus 270, that is 90 degrees. Since angle DCE plus angle ECF plus angle DCF is equal to 360 degrees, we can say that, so here we substitute the values, and then in the right side we have 360 degrees. So angle DCE is equal to 360 degree minus 270 degrees, that is 90 degrees. Okay, now once we know that this particular angle is 90 degree, this is the central angle of the arc DE. Okay, so measure of this arc DE will be 90 degrees. That means angle DCF is equal to angle DCE plus angle ECF, correct? Now why we need angle DCF? Since we need to find measure of arc DEF. DE we got, next we need to find DEF. For that I am finding the angle DCF, or else directly we can find the measure of the arc DE plus EF. Now DE is 70 degrees or 90 degrees, and EF is 70 degrees, so just add 90 plus 70, and hence you will get 160 degrees. Okay, so measure of arc DEF is 160 degrees. So either you add these two central angles and then say that measure of arc DEF is same as angle DCF, or find DE, find EF, and add these both to get the measure of arc DEF. Either ways you will get the answer as 160 degrees. Okay, so that was a simple question. Now let's see the next problem. Okay, so this is the second question in the practice set, wherein we have a figure 3.38. This is it. Wherein they have told that QRS is an equilateral triangle. Okay, equilateral means the sides are of equal length. All three sides are of equal length, and all three angles are also of equal length. And in equilateral triangle, all three angles are equal, hence each angle measures 60 degree. Since sum of angles of a triangle is 180, so if you divide it by 3, then 3 equal angles, that means 60, 60, 60 will give you 180. So this is an equilateral triangle with all sides equal. First we need to prove that arc RS, that is this particular arc RS, is congruent to arc QS and is congruent to arc QR. Okay, so there are 3 arcs which we need to prove that it's congruent. Now here we will use the theorem which says that if you have congruent chords, then the corresponding arcs formed are also congruent. So just by that, it's a one line proof actually. Triangle QRS is an equilateral triangle, therefore segment QS is congruent to segment QR is congruent to segment RS. Now segments QS, QR, RS are chords actually. So chord QS is congruent to chord QR is congruent to chord RS, okay, since they are sides of an equilateral triangle. Now the corresponding chords of congruent chords are congruent. The corresponding angles of congruent chords are congruent, okay. This is not chords, this is angles. Therefore corresponding arcs, okay, here we need to write arcs. I'm really sorry for this error. So corresponding arcs of congruent chords are congruent. Now here we have three congruent chords, so the corresponding arcs are also congruent. That means arc QS is congruent to arc QR and is congruent to arc RS. The reason is they are corresponding arcs of congruent chords. Next, second part of the question is measure of arc QRS is 240 degrees. That means measure of arc QRS is equal to 240 degree. That is what we need to prove. Now measure of arc QS. What will be measure of arc QS? Since all these three arcs QS, RS and QR are measure same, so if we add these three arcs we get full circle, which is 360 degrees. So if we divide 360 by 3 we will get measure of each arc, okay. So we have three circle divided into three equal parts. As such, the one part will be total angle upon 3, that is 120 degrees. So this QS is 120 degrees. That means QRS will be full 360 minus QS. So QRS will be 360 degree minus 120 degree, and that is 270 degrees. Or in other words, when we got that each part of it is there are three and each arc is 120 degrees. So here QRS, if you add QR plus RS, that is 120 plus 120, again you will get the answer as 240 degrees. Okay, so either ways the answer will be same. So here 360 minus 120, so this measure of our QRS is 40 degrees. Okay, this is the third question in the practice set, wherein we have two chords, congruent chords, chord AB and chord CD are congruent and they are intersecting. Okay, we need to prove that arc AC is congruent to arc BD. So here we will use the concept that congruent corresponding arcs of congruent chords are congruent, and then we will do few things. So let's see. Chord AB is congruent to chord CD, correct? That means arc AC is congruent to arc CBD, since they are congruent chords of corresponding arcs of congruent chords. Okay, that's the reason. Now measure of arc ACD. Measure this particular arc, which we can call it as ACD or ABD. Okay, this full arc can be written in two ways. One way is measure of arc ACD is equal to AC plus CBD. Okay, similarly measure of arc ACD is equal to arc BD plus arc ACB. Either ways we can write it, that is mark those points as point A and point B. Once you do that, anyways measure of arc ACD is constant. So in both cases the left side the value will be same. That means the right side also match. So measure of arc AC plus measure of arc CBD is equal to measure of arc ACB plus measure of arc BD. Okay. Now in these two equations, if you see CBD, measure of arc CBD and measure of arc ACB are equal since they are congruent arcs. Okay. So we can replace ACB with CBD. Again, then also the equality remains the same. Now these two things will get cancelled. Same numbers on both the sides getting added. So by cancellation law. So what will be left is measure of arc AC is equal to measure of arc BD. Okay. So same circle, if two arcs are congruent, have equal measure, not congruent, have equal measure, then naturally the radius is equal since the circle is same. So arc AC and arc BD are congruent. That's it. Okay. Okay, so I'm done with the video. That was a very small practice set, that is 3.3. So if you like the video, please share it with your friends and please subscribe the channel. You can also follow us on Instagram, and please ask your queries or doubts in the comment section. We will respond to you as soon as possible. So stay tuned. Bye.